The Koenigsegg Regera.
So this is the car, this is the Regera?
Yeah, this is your ride for the day here.
It's amazing.
Yeah, it's a very beautiful car.
Katie will be joined by Koenigsegg test driver Christopher Neergaard, who knows this supercar inside out.
I'll give you the key and then you can take it for a spin.
Thank you, let's go. Wow, and it's fully electric, isn't it, on the key fob?
Fully electric, yeah. Nobody wants to open doors anymore. It's so last year, so everything can be done on the remote.
Wow, that's amazing.
Costing over £2 million, this is an ultimate speed machine. Its hybrid powertrain can accelerate to 400 kilometers an hour, that's 250 miles per hour, and decelerate back to a stop in a world record-breaking 31.49 seconds. Wheels made of carbon fibre are lined with 24-karat gold. And its unique direct drive system pushes it from 0 to 60 in 2.8 seconds. There will only ever be 80 Regeras made, and today, Katie will drive one of them close to the limit.
Take it for a spin here.
Oh, wow, look at this. I love how it all matches the outside as well. The whole setup in here is really unique. Okay, so should we go?
So, yeah.
Wow, that's a proper noise, isn't it? That is awesome.
Put it in drive and then you're ready to go. You can just start out here, you drive just so you can see the end of the runway, so you just accelerate down to the end.
Full gas?
Yeah.
Ah! Oh my God, that's absolutely insane! Should we try again?
Yeah.
Ah, okay.
Oh, just hammer it.
Oh my goodness! Wow, that was awesome.
And the feeling of speed, you know, here you have wide open spaces.
Yeah.
So you were just going 170 k's per hour there, just like this.
Yeah, and that was like, you know, almost like 3 seconds, wasn't
Exactly.
it? Absolutely incredible.
Yeah.
How has Koenigsegg created a world record-breaking supercar? The answer is in a cutting-edge facility hidden in a hangar at the edge of this runway. In Ängelholm in Sweden is a former Air Force base. The squadron's insignia, a flying ghost, now adorns the engine bay of all Koenigsegg cars. The 4,000 square metre hangar has since been transformed into a state-of-the-art facility where this team of engineers create their supercars. All under the watchful eye of its founder, Christian Von Koenigsegg.
I would say it's a fairly unique place on planet Earth. We're kind of breaking the mold in many ways in what we're doing. We're doing it because we think we can do it better. We can combine features and functions and make things lighter or more efficient or safer or cleaner or better for the environment or whatever it is. It's like pushing all boundaries simultaneously.
Growing up, Christian Von Koenigsegg was fascinated by cars. But for him, the thrill wasn't the speed, it was how they worked. So in 1994, with no background in car engineering, he set out to build his own supercar, the CC. His goal was to create groundbreaking machines. And just 2 decades and a handful of supercars later, he's done just that with the Regera.
This production line is consisting of 8 stations, and we're about a 1-week cycle, so we move the car forward 1 time per week. So it's a 1-week production cycle of cars coming out.
It takes on average 10 months to turn raw materials into a finished record-breaking supercar rolling off the production line. The build begins with the chassis. And production station leader Tim Beck is giving us a rare glimpse of where this car starts out life.
This is station 1. This is where we start production of the car. So this is the first station. We build the monocoque of the car.
Originally developed by Formula One designers, a monocoque is where the chassis and main bodywork are built as a single structure, dramatically increasing its strength.
All the structure of the car is in the monocoque. There's nothing else outside, it's just bodywork.
To stand any chance of getting to its top speed, this structure needs to be as light as possible.
It is not heavy at all. You can just take it and lift it like this. 2 people can lift it and carry it away. Sorry, Henrik. He's just working on it back there. But 2 people can lift it up and walk away with it.
The secret to the car's weight lies in the material of the monocoque. Carbon fiber.
It's a tested method. Racing cars has been doing this for ages, but it hasn't been implemented in normal street cars until recently. The chassis is built up out of 10 different pieces, which are all hand-layered carbon fiber. We tried to keep the tolerances below 0.5 millimeters, which is quite difficult with such a lively material as carbon fiber is.
Tim's team's handiwork has got to be precise. They can't afford any mistakes.
It's sort of the skeleton of the car. If one piece here is a bit off, 1 millimeter too far out here, that makes the roof so that the roof doesn't fit. The roof gets, this is where the roof locks goes. And then in the back is also where the roof locks goes. So the better we make it here, the easier it'll make for everyone on the production line.
Once the parts of the monocoque have been created, to ensure extra strength and an even load, they're glued together like a massive model kit.
The adhesive that we use is a 2-component epoxy-based glue, a structural adhesive, and it's the only thing we use to put the car together.
Just floor it.
On the runway outside,
Oh my goodness! Wow, that's insane.
Katie is testing just how the weight of the supercar can impact the speed.
Almost 100 kilometers an hour, just driving along, just chatting, going from side to side, and you're not feeling anything. So light.
And it is, in fact, you know, it's a combination, but the heart of the chassis, this monocoque, the way that the Koenigsegg is built, it's, you know, it's made from this, so it's light and stiff.
So when you think about how light that actually is, it's not really that surprising that you can actually keep the grip and corner at such speed with a steering input. It's very, very responsive. And I think that's partly down to how light the chassis is, but also the strength of it, you know, it's holding everything in place. You have a lot of confidence in how much you can actually push this and how well the chassis handles, actually probably handles better at higher speeds.
But creating a road-legal supercar that could give any machine on the racetrack a run for its money is a huge engineering undertaking. It requires all the tricks and technology of some of the world's most advanced engineering minds. In a small town in Sweden lies a clutch of hangars where Koenigsegg builds its record breakers. This plug-in hybrid has a top speed of over 400 kilometers per hour, which it can reach in just over 22 seconds, thanks in part to its lightweight carbon structure. But its more than £2 million price tag puts it out of reach for most people.
I think we actually have changed the automotive landscape to a certain degree with our ways of doing things.
This might be one of the fastest cars on the planet, but supercars might not even exist if it weren't for a pioneering trailblazer that changed everything. In Hampshire, vehicle engineer Titch Cormack is getting to grips with one of the world's first supercars.
Oh, wow. This is fantastic.
The Jaguar XK120.
I mean, look at this. What a wonderful machine.
First produced in 1948, this is one of the most iconic British sports cars ever made.
If you just look at the lines on this car, it's absolutely perfect. But it's probably one of the nicest cars I've ever seen.
This car wasn't intended to sit in collections. It was built to be driven.
Loads of torque, loads of pull. She's handling beautifully.
But handling a 70-year-old sports car isn't for the faint-hearted.
Yeah, oh, I don't want to. Hang on. Oh, come on, get in gear. There we are. And it jumped out a second. Whoa, and there she is again. OK, we're up into third. Let's stick with third.
Rumoured to have been designed in less than 2 weeks, the XK120 was a mere carrier for a game-changing new engine.
At the time of conception, Jaguar were helping with the war effort. So William Lyons and a team of engineers, while on fire watch on the top of Jaguar factory, came up with the idea of the XK6 engine.
The newly developed engine was streets ahead of the competition.
The 3.4 inline six-cylinder engine with double overhead cam produced 160 brake horsepower. That's hot, by the way. I've just driven this well, and that's a little bit warm, but we don't worry about that. This was £1,250. That's about 44 grand in modern money. And this was a true supercar of the day. That brought supercar motoring to the masses.
The XK120 was named for its claimed top speed of 120 miles per hour, but some were sceptical it could reach that. So, on the 30th of May 1949, Jaguar invited the world's motoring press to a closed section of motorway in Belgium.
With journos lying in the carriageway, Jaguar went for it, the flying mile. They needed to achieve 120 miles an hour.
The white left-hand drive car, which was only the second XK120 to be built, absolutely flew down the carriageway.
They did it. They achieved 133 miles an hour. Back in 1949, imagine that. That's absolutely incredible.
The XK120 was subsequently declared the fastest production car in the world.
And I'm about to do the same here. However, I'm on a road in Hampshire, so I've got a 60-mile-an-hour speed limit, but let's see what she can do. Here we go. 40, 50, whoa, quick, 60. Wow, she's still got it, I tell you.
Thanks to its speed, looks and affordability, the Jaguar XK120 became known as the world's first supercar.
I tell you what, this engine still pulls superbly. And it's amazing that this car, when you think about it, it's 70 years old. This is as old as my mum. Jaguar went on to become synonymous with motor racing and cars in general. And it's all thanks to the XK6 engine, developed in 1948.
Every advanced supercar developed since carries a bit of the XK120's DNA, making it one of the most important cars of all time.
Whoa! Yeah, baby. Yeah, it's still got that power.
The Swedish translation of Regera is terrain. And topping the timesheets at 400 kilometers per hour, this supercar has a claim to be motoring royalty.
There's so much innovation in this car. They've put thought into every single system, keeping it light and keeping it fast.
And the secret of this supercar's incredible top speed is held in this modest factory. At the centre of its design is its extraordinary engine. Alec Bialek heads up the powertrain software department. It's up to him to get the most speed out of this supercar's power unit. But under the hood of the Regera, size isn't everything.
The Koenigsegg V8, we like to say, is the world's most downsized engine. So while it is not necessarily a small engine at 5 liters, it does have the highest specific power if you measure that power in horsepower per liter. And so the power we're able to get out of it is truly on a whole nother level from anything else in history.
Thousands of components are used to build just one V8 turbo engine, which means the small team here can only make 30 power units a year.
We have our whole own engine shop here, and it's not just that they're assembled on site. The design of them is also done completely in-house. We cast our own blocks, we cast our own heads. So you'll find on every single engine here that you see in the factory, there's a little shield with a nameplate on it, on each engine. And this is the nameplate for the engine builder who built it.
All of this incredible engineering means that the Regera can reach a top speed of over 400 kilometers per hour.
From 0 to 200, you are just being pushed into your seat. It's like being in an airplane when it takes off, except we're traveling twice as fast as airplanes do at the end of the runway. So it's pretty outrageous to be in.
So now the GC and everything is off, you just floor it, and then you really feel that the power is there.
Okay, so we've turned the systems off now.
Exactly, the systems are off.
And outside on the runway, with the traction control turned off,
180 degrees and
Yes,
floor it.
and you just floor it.
rally driver Katie is feeling firsthand the full force of the V8 engine.
You see?
It's almost a 360, I don't know about 180.
Yeah, it was close to that, and that, as you see, the power is there and it's instant there all the time. So it's really powerful. You have the helping system there to help you to drive it. If you want to take it off, you can have fun and still, you know, bring it to the edge and a little bit above, as you can see.
And it's a talky car, there's no delay there at all. I think I left some rubber on your track over there as well.
Yeah, it's fine, it will match the rest of it, it's all good.
In his ex-Air Force Base facility, founder Christian Von Koenigsegg is pushing boundaries.
I had a childhood dream. I wanted to build my own sports car for as long as I can remember, pretty much. And here we are, almost 30 years later, developing, designing, testing, producing, and delivering extreme mega cars to the world market. It's very exciting.
The click of a button will open all of this supercar's automatic bodywork. Under the auto skin lies the world's smallest, most power-dense automotive battery system. And a powertrain capable of propelling the car from 0 to 300 kilometers per hour in a blistering 10.9 seconds. With many recent supercars, a lightweight carbon fibre chassis and body has become the norm. But there is one part of the car which still remains fairly heavyweight: the wheels.
So there is a simple way of looking at it. You should try to make your car as light as possible as a whole, to make it as little mass as possible to push forward when you accelerate, and as little mass wanting to continue straight forward when you turn, so you can turn better. So by reducing the weight of the wheel, you have a nicer steering feel and a better reaction to the car.
Every gram saved in wheel design helps to allow the car to maximise traction. Whilst alloy wheels are good enough for some, Christian saw it as an opportunity to innovate. But what was the secret to solving this problem? At a facility in Norwich, a team of skilled experts is producing one of the industry's most versatile materials, carbon fibre. And overseeing the whole process, engineer Mike Harris is getting a closer look at how it starts out life.
So carbon fibre is a woven material, and it comes together as multiple different strands. As you can see, I'm pulling this. It's incredibly strong. I can't break that. It is mind-blowing, and to think that you can design things that are a half to 2 mil thick for the same properties as something 10 mil thick is phenomenal.
At roughly 7 times thinner than a human hair, these tiny fibres are woven together to form a mat and stored at sub-zero temperatures.
The dry fabric has a resin applied to it, which is why it's stored in here. The resin needs to be stabilised at minus 18 degrees. I'll show you a piece that's been in the freezer. So here's one in kit form. If I take a piece out, if you hold it up to the light, you can see that's a 200 gram, and you can see through it. So you can see how thin it is.
Once selected, The rolls are then cut to size.
It's very accurate. We can cut within 0.5 millimetre. So once it's been cut, you have a kit, as you would have here.
Compiled of numerous thicknesses, shapes are transferred to the laminating room.
So we take the kit as it was cut and we put it into the mould. How these plies go down is extremely critical. It's a very skilled job. You can see the beauty of a carbon fibre part, composite part, is that you can build it up in the areas that you need specific strength.
To evenly and firmly bond the layers together, the wing is vacuum packed before going in the oven.
The next stage is to put it into the autoclave. The autoclave is effectively a pressurised oven that applies pressure to the part, and the heat allows the resin to flow within the part.
The autoclave cooks the composites applying pressure of 120 psi, roughly 8 times the atmosphere.
This is our part here, ready to go in, and in doing so, the plies will be consolidated under that pressure, the resin will flow, and the part will set hard. This is the part of the process where the part goes from a fabric to a solid part. At this point, it gets to a point of no return, I suppose.
This part will be baked for 2 hours at up to 130 degrees Celsius until the fabrics have formed a solid component.
It's really exciting to see parts at this stage of the process, especially new development parts coming through.
Once cooked, they are then bonded and sent to finishing before visiting final inspection.
It's great to see the product in its final state. If you think about where it's come from those loose fibres, you can see how absolutely rigid it is, and I don't mind putting it on there, and there's nothing you can do to that.
The carbon fibre revolution is now so synonymous with the supercar industry, it allows companies like Koenigsegg to rewrite the rules of car production.
It's unbelievable. I've been in the manufacture of carbon fibre parts for over 25 years, and it's still amazing when you pick a part up. You almost drop it because it's so light. Are we pushing the boundaries? Yes, I believe we are here, and it's just a fantastic material to work with.
Although featuring his in-house composites throughout his supercars, Christian Von Koenigsegg's pursuit of maximum speed has led him to take its use one step further by creating the world's first hollow, fully carbon fibre rim.
So here we are making our famous hollow carbon fiber wheels. If you look inside the wheel, we have cut a spoke apart here. You can see it's actually empty inside and hollow. This is also completely unique. So a wheel of this size weighs like 5.9 kilos. It's quite light, so it's not much exercise doing this.
Back on the airstrip, rally driver Katie is experiencing the result of a wheel that weighs up to 40% less than its alloy counterparts.
Yeah, this is something special. I have to say, I don't know if it's because the wheels are so light, maybe that and the combination between that and this carbon fibre monocoque chassis that we've got. The reactivity when you're actually turning is absolutely phenomenal. I haven't experienced this in a car before, the way that it's so nimble and it's so responsive, but also so well behaved.
Back in the factory, one of the key elements the team are working on is perhaps the car's most notable engineering achievement. The car's eminent powertrain is the next assembly phase. When developing the Regera, the team went back to the drawing board to see where extra speed could be found. The result was a one-of-a-kind hybrid propulsion system, the Koenigsegg Direct Drive.
So it's a 5-liter engine with 1,200 horsepower, plus we have electrification. So here we have an electrical motor sitting on the crank of the motor. This one gives 200 horsepower extra. And then we also have 2 more electrical motors on the rear axle, and they are both 250 horsepower each.
The unique Direct Drive uses 3 battery-powered electric motors to launch it off the line at breakneck speeds.
Electrical motors push the car forward when needed, and they are very, very powerful at these lower RPMs. And when you get up to a speed where you can actually achieve what we call direct drive, which is around 35, 40 kilometers per hour, your combustion engine gives more power at a fairly low RPM at that point. And also the electrical motors, the 3 electrical motors, push the car forward. But if you push a little bit further on your throttle, when you hit around 250 kilometers per hour, there is no need for that anymore, because then the combustion engine is in its perfect power zone. It's a very simple solution in many ways. It's inherently smooth. The interaction between the electrical motors and the combustion engine, let's say the components just like each other this way. What this means for the driving experience of Regera is that the power is immediately accessible, and you can basically go from 0 to 250 miles per hour by just pressing the throttle and holding on. It's like synaptically connected to your brain what's happening in the car, because it's so instant at the same time.
By using 2 different power sources in this way, the hybrid direct drive system propels the car from 0 to 400 kilometers per hour in an acclaimed sub-20 seconds, and without needing to shift gear once. And outside the factory, along the 1.7 kilometers of runway, Katie is experiencing this for herself.
First time, it's actually overwhelming, you know, how fast it goes, even if you're used to driving fast cars. And actually, you've got 2 motors on the rear wheels, that's correct, isn't it? Mounted onto the drive shaft, and each are putting out 240 brake horsepower to each wheel.
Exactly.
So it's, you know, when you're thinking in those relative terms, actually, it doesn't surprise you that when you put your foot down, it really, really goes.
And that's the thing with this car here, you're saying you have this one gear, so it just keeps on pulling. You don't have it where it goes to the rev limiter and you have to shift gear, it just keeps pulling.
Actually, you lose that form of perspective. Like when you're driving a manual, you shift gears, so you know kind of where you're at, because you're going right, second, third, okay, we're getting up there now. But this is actually, it's like being in some kind of aeroplane. That's what it reminds me of on the runway when you're taking off, and it's
just infinite power. It just keeps on pulling.
But whilst the driving experience of this car remains paramount, what happens if you strip away all creature comforts and simply aim for pure, unadulterated extreme speed? Santa Pod Raceway, the home of European drag racing, showcasing some of the most outrageous cars in the industry. But for all the extreme speed on show, there's one car that takes it to the next level. Fire Force 3 is the fastest jet funny car on the planet. Funny car is the name for any dragster with a tilt-up body on top of a custom chassis and engine. And it's Martin Hill who has the responsibility of taming this extreme example.
I think it's one of the most special cars purely because it's turbine powered rather than a combustion engine. So there's no drive through the wheels, nothing. It's basically, you can akin it to a air dryer on a roller skate.
But gaining fame by destroying the quarter mile with over 10,000 horsepower equivalent, this car has some hefty propulsion.
As you can see now, you're looking at the power plant. When the engine spins up, you've got air being sucked in the compressor, gets introduced into the combustion area. That light gets forced over the turbine wheels, out through the back, and that's how you get your thrust. It's as simple as that. Basically, it's a low-flying aircraft. Everything's designed that we only have what we need. We don't carry anything extra. The only thing extra is a bit more pounds on me.
And today, despite the bad weather, the crowds at Santa Pod are gathering to see this legendary car put on a rare nighttime spectacle.
We've got basically all 4 wheels freewheel, so we need grip for stability, not for drive. So you've got to run on a dry track because obviously the turbine will determine which way the car goes at speed.
capable of speeds of up to 336 miles per hour in under 6 seconds. To this day, the record-breaking Fire Force 3 is one of the fastest accelerating machines in the world. A pioneering new supercar, the Regera is produced in this advanced facility in rural Sweden.
The powertrain unit in the Regera is truly unlike any transmission concept that has ever been seen before, but still is completely drivable and comfortable to be in and kind of usable power. It's never super terrifying.
Each one built to an entirely bespoke specification, this hybrid production car has well over 1 megawatt of power. And with nearly 1,000 horsepower per ton, this is one of the most powerful hybrid production cars ever produced.
I think it's for sure one of the most technologically complex cars that's around. It has a lot of very, very crazy technology going on in it.
But what good would 1,500 horsepower be if it didn't have the appropriate coat and tie to match? In the finishing stage of production, the Regera's groundbreaking automatic bodywork is installed and checked. Its bold aesthetics may be fitting for a supercar, but its very shape hides a lot of its secrets to going fast. Marcus Harder is in charge of the manufacturer's aerodynamics department.
When you're designing a car, you need to focus on two primary things with aerodynamics. One is drag, the other one is downforce. Drag is generated as soon as you want to move something against the air. It's the resistance you're facing. The other thing is downforce. When you're accelerating, you want as little downforce as possible, but you want enough friction to keep the tires from spinning uncontrollably.
To balance both drag and downforce, the engineers have developed the world's first top-mounted, fully retractable active rear wing.
Here on the back, we have our rear active wing, which we can tilt depending on what kind of aerodynamical feature we want. If we want to accelerate at really high speeds, then we lower it to create less drag. But when we are braking, then we want to create as much downforce and drag as possible, so then we use it for aero braking. The wing itself is automatic, and it's depending on the throttle you give, the brake you give, the steering angle, and then reflected thereafter.
It's a crucial role when you want to go fast and stay fast.
I think with the velocities and the power you have in this kind of car, you really need to stick the tires to the pavement.
Back on the airstrip, Katie's finding out exactly how this aerospace engineering helps to keep this supercar playing nicely.
You really get that sensation of actually this is endless. You know, I could have kept going there, worried about running out of room on the runway more than I am the car speed. But
Exactly.
And finding out that not only is the Regera an out-and-out speed machine, it's a forgiving one too.
it's got so much to give. I think that the only limiting factor of this car is the driver and how much you trust it. You know, that's really the feedback that I'm getting. It's safe, it's fast, but it stops as well. There's not a lot of transfer in terms of handling. When you hard accelerate and then you brake, it's very stable.
And taking from the foundations of the active bodywork, the team have pulled out all the stops and created another world first.
One of the party tricks of the car is that all of the panels on it are actually automated.
Their groundbreaking, fully robotized auto skin.
So with one push of the key, you can actually open up every single panel on the car. Frankly, it just looks pretty cool. And it's a pretty unique feature. The benefit of it is that you never need to touch your clean car, so you never get fingerprints on it.
But maintaining their lightweight ethos, Alec and the team couldn't afford to take their eye off the scales.
The bonus of it was that it was almost free for us to do in terms of weight. The system is a piggyback on the hydraulic system. If this system weighed 200 kilograms, it would not be worth it to put in. But we were able to put it in with almost zero weight penalty, which at that point becomes a win-win. It's not exactly necessary in any sense of the word, but it absolutely is another little detail that is part of what makes the cars exactly as special as they are.
Creating one of the world's fastest cars is a monumental task. But having risen to the challenge, the Koenigsegg Regera is breaching frontiers that were previously untouched.
It doesn't matter how many times you go down the end of the runway and you accelerate, every time it's just like, oh my God, this is awesome. It's an absolutely incredible machine. I've actually never experienced a car like it.
And with just 80 being made, this rare gem will be reserved for only the most exclusive of highways.
We like doing our cars and being a very small, agile team of people that are just crushing it and making the coolest cars we can.
I would call it the king of what it does, absolutely. I think we're really leading the technological development in this field. My inspiration is basically to push boundaries and to show the world that anything is possible if you really put your mind to it.